Morning, everyone. I hope everyone is doing okay. Let me know if you can hear me fine. And welcome to next session of BeSA. We are on week 11th. I was not able to join last week. I really missed the session, and I hopefully Prasad and Kapil have delivered a great session on interview, and you enjoyed it. And we would continue today, and we would have Parna and Prasad also helping us. So let me add Parna to stage for a minute, Prasad. But before that, let me ask you a question. Have you been to any vacation or planning for any vacation? I wanted to highlight it because I had some great time in Scotland last week. So I just wanted to share some of the things which I have done here. So Scotland is nice if weather is nice, otherwise it's a miserable place. But yeah, luckily there was a nice weather that time. So this is Scotland Castle. And then we went out for a few places. It was really nice weather, really bubbling with a tourist and lots of activities happening. I didn't realize, but when I booked this tour, there was a Taylor Swift concert there. So it was so complicated. Means everything was booked, everything was packed, but still we enjoyed a lot there. It's a beautiful place. As I said, if weather is good, you would have enjoyed it a lot. And let me know if you have been to any places which you could recommend or any place you are planning to visit into some time. So let me know. I can get some inspiration. I have still some leaves left, so I want to probably use that to make most out of it. So it was a nice place and weather was really nice. Hopefully everyone has been to them. I have been to Vaishno Devi in India last week. That's a good one, and it's a you need to have like a lot of physical struggle also. I guess in Vaishno Devi you have to go on a hill, so that's a good thing for physical exercise. For me it was not that complicated because I was mostly into a Uber or maybe into a guided tour. Went to Malaysia. Malaysia is a nice place too, Anupama. Nice, good to hear that. What about others? Anyone else been to any other places or planning to go to any other places? And yeah, I saw this statue, if you probably know, if the statue in the middle, which I am showing right now on the screen, is coming from a park in Edinburgh. And this bear was a part of World War. So he was with Polish army and somehow he helped Polish army also in some of the campaign. So no idea how, but yeah, this is the statue which they have erected in honor of that bear into Polish army. And obviously lots of things, and if you can see on the right, cow, this is very well known face of Scotland. So that's all, but yeah, hopefully I would have more time and I would share more memories and pictures with you. I really feel happy to be again on this track, and let me now add Parna and Prasad also to the stage. How do you team a beer? I have no idea on that, Cynthia. Means I'm not at all a beer tamer, so no, cannot suggest anything. But yeah, probably people know about it, and that's how. Scotland is beautiful. I agree on that. I agree. Planning Vaishno Devi trip when visiting India next month. Good, Prasad. That's fine. Pokhara, Nepal. Wow, that's a good one.
Ashish, while you were
I
in
like your name,
Scotland,
Kids Travel Vlog with DDM. Varna, you may be on mute.
and Ashish, while you were in Scotland in Edinburgh, did you get chance to go to Arthur's Seat? That's a quite a
Uh,
steep hill.
I see. I know that you would ask that question because you are more into trekking and all. I am not at all in that. I'm a lazy person. So you give me a seat, give me a cup of tea, and I'm happy sitting there, not walking. Arthur seat, at least a half an hour or at least an hour walk is there, I guess. So I didn't dare it. My son was asking, but said if you want to go, go. I am not interested. I am enjoying vacation. I am not in the mood to perform any labor at all. It's a nice place. We saw it from out
Yeah, yeah,
from the back side, but we didn't
yeah.
climb the mountain. Didn't climb that particular
No,
plateau.
it's a
But yeah,
quite steep, but the views are
yeah,
really good once you go up
views are
there.
really
Yeah.
nice. I agree. And this was like there was rain, but for a while it was raining, and most of the time it was very sunny. So it was really nice to that. Yeah. So Pawan is
Cool.
confirming that he climbed Arthur's Seat. That's good. Once the season can't plan. Lakshmi, I'll share my tip. When I was in Bangalore for a long time, and whenever it was monsoon, I used to visit Goa. Though they close the beach, but Goa is completely different when it is monsoon. That's my personal thing. So I enjoyed it. I could not go to beach because they were closed, but overall Goa is very beautiful even in monsoon. So if you get time, try that. All right, good. Thank you. So we will continue, and today would be a discussion on a container. So we will discuss that. So Parna would be a customer. I would play a role of an individual who knows about AWS. So let's say thank you, Meryl. Hello from Goa. Good to see that. All right, good. So let's continue.
Very
Prasad,
quickly,
you want to talk about something?
yes, very quickly before you folks get started, the Discord channel. Let me paste the link
Yeah.
again. Let's see. Hopefully, it will reach everyone. I know it's not very active, but I see few people started asking technical questions and stuff, which is great. So let's continue doing that. Uh, it'll take some time for us to streamline stuff, but yeah, as a community, let's do it together. So feel free to join and let's make the Discord channel active. And any questions or any progress that you're making in your learning journey, feel free to share it. It'll help others in a way to inspire them, and we all can uplift each other. That's all from me. I'll go off screen now and we'll let Ashish and Parna take over the session.
Yeah, means just wanted to talk about Discord too. Like it's a nice place. I am also very new to it, but I am liking it because it's very interactive. And obviously it is a closed group. So feel free to ask questions, feel free to share learning. If you need any advice or anything, feel free to join the Discord. We would try to keep it active, but obviously we would need your support to keep it active so that everyone can get benefited from it. Okay. All right, let's continue, Parna, and welcome. And let's discuss about one of the things which is used a lot by a lot of customers of ours, which is containers. How can I help you today?
Sure. Hi, Ashish. I'm glad you're here. And my organization has been working on a lot of small projects, and just traditional way we have a whole lot of monoliths. We have legacy applications, and the maximum we've modernized is gone on to multi-tiered architecture. So we are really looking forward to learn from you today. How should we go about containerizing our workloads? Some of the benefits, and we obviously wish to use AWS for that purpose. So if you could enlighten me with those topics, it will be great. So firstly, I would want to know is everybody knows that you need to modernize your applications, go for containerization. But where does containers actually fit into my application architecture, which I'm a little confused about? If you could explain that to me, that will really open up our minds.
Makes sense. Yeah, means it's quite easy to get overwhelmed because there are so many things available into modernization world, and there are event-driven architecture, there are containerization,
True.
microservice architecture. So let's me try to give you an understanding of that how we came to this stage, that what was the motivation to come to containers and where they actually fit in. Give me a minute. I'll get started and share screen with all of you. So I'll quickly focus on that how our application have evolved over a period of time and where container actually fit in, what containers actually are. They are not a silver bullet who can solve every problem of yours, but yeah, it fits in into a very specific use cases. Let's talk about it. So if I take a little bit of history lesson, I'm talking about four things here. What is the development process? How people used to develop software, how application architectures were created, and how the packaging of the application happened. Once you have created your application, you want to put it to production and move forward. So that is called deployment and packaging. And then we host our application into some platform. So let's see how it evolved. If I'm talking about little early 1980s to 2000, that time the development process for software was something called waterfall model. There was some challenges with it. It was not completely wrong. It survived for long, but the problem was that it was a very linear approach. So if I wanted to build a software, I have to maybe wait up to 1 or 2 years before that software is actually seen into production. So that was a challenge here. And then if I had to make some changes in the on the fly, it was not very well accepted into this model. This is called waterfall. As a waterfall, it always goes from top to bottom. There is no way for water to climb up again. Same thing, once you have removed from a phase and moved to next phase, you could not go back to the first phase. So requirement gathering, then you perform analysis, then you perform development or design, then you write the code, then you deploy it, test it. So that was complicated.
I
And that
realized
time
this, Ashish, because in Waterfall we've seen that there were some features at the end. We realized that hey, we did not account for that,
did
right?
not account
So,
for exactly.
so that's a
So
problem in this process, I guess.
Yeah, it means if you have, let's say you completed your requirement gathering, and if you miss the requirement, then you won't be able to go back and say, hey, I missed it, I
Right.
have to start again, because then you have to start the whole waterfall again because it was a linear process.
Yes.
And when we deployed this waterfall type of application were designed to be a monolith. That was the only option available, that we would deploy as a one single code base. We would decide at the very starting point, I am going to use Java or .NET or PHP for my application, and everything is one single unit which I am deploying. And the packaging that time around 80 and 2000 was physical server. So you need to deploy application, let's take some physical server, combine them maybe in a cluster, maybe host a database, and let that started get with the application. So that was our deployment and packaging of application. And customers were hosting these application in their own data center so that they could have full control and they have visibility what is happening. They were maintaining these things because there was no other option available. So this is what initial architecture of application was. Change thing changed thing changed into 2000 and 2010. People did not want to wait for their idea to mature in 2 years and then see the product is not working as expected. So they came up with the idea of agile. We would have shorter loops rather than going through the whole life cycle. Let's just create a small portion. Let's create what we sometimes call MVP, most viable product, and then we move from there. So we started doing agile. Agile had faster iteration. We were able to have better sprint, and because of that, we were able to get my result of software application much faster. And when we came to agile, we need to also scale our way of deploying application architecture. N-tier architecture, 2-tier, 3-tier, they become very common. And then deployment and packaging started happening on virtual server, because by this time VMware, Hyper-V became mainstream player into environment, and customers started using these virtual servers. So this is how we have evolved.
I
And
think
by this time,
Ashish, I just sharing my views because we have both of them in our organization. I guess in the first approach in monolith, I think there was a lot of over provisioning we had done. So a lot of waste of resources and compute and memory we had over provisioned. I think we could refine it a little better in the second approach, because every time we were getting feedback and we were tailoring it. But I guess you containerization makes it even better, right? If I'm not wrong, I think
yeah, agreed.
we
Means
are
we will
getting there.
talk about that, but you are completely right. When we had this physical server format, we had a one-to-one mapping. One server, one application, nothing beyond it.
Right.
Now, industry averages that we use only 10% of server capacity we have provision in physical world. So you have bought a server which had 8 CPU, 16 CPU, and you are using what? You are just using 10% of it. It's like
Right.
getting into a big apartment with 100 rooms and you are just single person and you are staying into one room, you are wasting a lot of resource. So we improved it. We started using virtualization, and by this time the other service provider like Rackspace have become very common. So customer realize that, hey, I have to run 2 server or 10 server. Do I need the full data center? Can I not just buy or borrow or rent or lease server from companies like Rackspace? So this time hosted service provider become very common. Are you clear on this so far?
Sure. Yeah, it's making sense.
Now, things were okay, but obviously IT industry is always evolving. So we started evolving our application. So 2010 to current, if I talk about, DevOps came into picture. So DevOps ensured that we are able to do things much faster, and there is a more collaboration on that. So DevOps came into picture, and by this time we realized that it's better to break down application into microservices. So microservice is a smaller component of your whole application which is doing one specific task. Let's say your whole application is amazon.com. One microservice in that could be a payment processing. And even payment processing may have multiple microservices like fraud detection or maybe verification or maybe sending an email or confirming a transaction. So that can happen into microservice. So they become smaller. They are doing
So
very
Ashish,
specific
I've
tasks.
got one question. So when we had multi-tiered or three-tiered, aren't we also breaking it down? So how is that different from microservices? There also we are kind of doing loosely coupling, right? So
It
how
is
is
loosely
this different?
coupled, but in microservice, we are mostly talking about something called polyglot persistence, and we call it polyglot uh, polyglot persistence, and polyglot framework.
So in
Idea
different
here is
languages, are you saying?
exactly. So even in entire architecture, your application is still a Java application or a .NET application or a PHP application. In microservice, we say, looks like the front end will work best into Node.js, so let me build into Node.js. And for that, maybe I would use DynamoDB as a database, so that I'm using a different database and I'm using a different type of my framework. Then I may say this one particular application will work best into PHP and I want to use SQL. So persistence is I am using my own choice of databases, what we call purpose-built databases. So I would use that. And then framework is I would use any languages which I feel comfortable or which are more suitable for my purpose. So it gave us independent, and then these are all talking over a well-defined API calls. So that encapsulate whatever is happening behind the scene. I am talking to an individual service. Is it in Java or .NET or PHP? I don't care. I have a standard API exposed and I am just consuming that API. So I have to make my application in a manner that it just consumes API, talks to another application rather than worrying about what that application is made up of. So it makes collaboration and scaling independently these components much easier. Does it make
Okay,
sense?
and yes, makes sense. And like you said, each microservice could have their own data source, right? A purpose
Could be,
built.
yes. So
Yeah.
it's there, and we always say that microservice should have their own persistent layer. So sometimes what customers think that, hey, I had a big service and I have just broken down it into two components and they are talking to each other directly. Then it is not a good approach, because in this approach, if this one fails, then second service is also of not use, or vice versa also. So in microservices, what we assume that we won't be directly using a storage tier. We may have something like this is my service A. That service may be talking to a persistent storage, and on that persistent storage my data has been saved, and B service will be picking up from here rather than communicating directly with them. So this is how we are externalizing the state and ensuring that we do not have any tight coupling of any component on that. So this is how we ensure proper connectivity.
I get it. So does event-driven architecture also can be considered a subset of microservices?
Almost yes, because there are multiple patterns to implement microservices. That could be one of the pattern we can use for that could be a event-driven architecture. So yes, EDA would be probably better implemented when I'm using microservice-based architectures.
Right. So they won't be talking via an API. So they'll be talking based on event that is emitted, and somebody would be the service
Yeah,
would be reacting to that.
still it may be happening through API, because let's say event happened and your function want to talk to a database or database
Hmm.
want to store something. So that can still be happening on the
Got it.
API level, but it may be triggered through an event rather than a standard flow where somebody is coming in and then a standard batch type of processing happening. So it will be more driven from an event.
I get it. Yeah.
Good. Now, if you say that I have broken down my application into smaller component, obviously that would mean I won't need that much of CPU memory and other capacity to run for it. So that is where containerization came into picture. We started packaging this microservice architecture, microservice components into a container. I will talk more on the container, but containerization provided the best platform to run microservice, because they were independent, they were small, they were very small in sizes, and they can run and start efficiently. Container fit into that particular requirement really well, and that's why for our microservice architecture, mostly deployment and packaging would be happening through containers. Are we clear?
So I have a question. I mean, yeah, we use the term container. So isn't this like a ship's container? So what's the relationship between them? Why do we use it? Maybe
Yeah,
you
that
can
is the
explain with
interesting
an
thing. I
analogy.
always say that technology has not come from outer space. It is driven by the day-to-day life things we do, and that's why I prefer explaining things through analogies. So I'll explain you that option also, that how container into physical world have generated a momentum into computing also. So we will talk about that. So this is my containers, and then application hosting by this time become more onto cloud provider side. customers started trusting cloud, customers started moving their application. So container cloud microservice DevOps is what we call new paradigm to run our application nowadays. Nobody talks about monolith or data center hosting or maybe creating virtual server. They are still very relevant, but if I'm talking about a modern cloud native application, probably I would be sticking to the bottom line, whether I'm using DevOps for development, I'm using microservice based architecture, I'm doing containerization, and I am running my application on cloud provider. So this is how it may look like. Okay.
So Ashish,
Now,
I understand that the modern way of doing it is on the cloud, but I can still run my containers on my on-premise servers
why not?
as well as
And
VMs,
even
right?
you can run in hybrid fashion. So I'll talk about some of the hybrid services where you could say I have my management sitting into cloud, but my containers are still running on-prem. I want a connectivity between them. So that is also possible. So flexibility is there. It is not like you cannot run it, but you need to weigh in whether it makes sense to run on-prem or not. Technically, yes, but business-wise, application-wise, you still have to consider a few components around it.
Right, because where your data resides as well, latency
Exactly.
compliance.
And then maybe your data still resides in on-prem, but you are
Yeah,
making a lot of computation or calculation on data from cloud. So accessing that data from on-prem to cloud may not make sense in long run. So that's how we should be looking into different aspects. So as I say always, it depends. Yes, you can run onto on-prem or you could run into container into cloud. It's purely your decision.
got it.
Now, the question you asked that how containers in shipping industry has helped us into creating similar structure here. So let's understand that how shipping industry evolved, because obviously it was not from very first day shipping started with container. What I'm showing right now on the screen, it is how a shipping industry used to operate. So there were no fixed way of moving stuff. Volume capacity calculation and then weight calculation, then saying that how much we would be able to load on a ship, how much capacity it can carry was very complicated, and everything was a manual task. Why? Because there was no standard. Obviously, let's say I'm sending oil to someone, there would be a different capacity my ship could carry. If I'm sending somebody, let's say, cotton, it would be a different capacity which would be carrying. So this is what containers used to happen. So yes, Cynthia, it is a history. History is always important. That gives you idea that how we actually evolved. So yeah, it is little bit of that. So shipping before container was like that, and then somebody thought that around like 50 years back, they thought this is not a best option to send stuff from ship to one country to another country. So let's create a standard unit. So this standard unit, if you see physical containers, they are all of the same size. They all have similar standard. They all have similar component to connect and then maybe loaded or uploaded on that. So multiplicity of the goods which we had to ship, that was very complicated. So what we came up with a standard way of shipping things that became container. Like if I give you my example, when 5 years back I moved from Dubai to London, I had to bring some stuff with me. I had checked with services who could help me move. They gave me two options. One was I pack everything in an individual box, label them all together, what is inside, all the detail, and then they will charge me on the box by box basis. Second option they gave me, book a container and we can put all the stuff you want into that container. Even if you want to carry your car with you, we would be able to fit in car hopefully, and then you could use the whole container packed at your end. We will deliver it and then you unpack it and we'll take away the container. So it was so much easier for me to move in that manner because I didn't have to worry about individual packaging or individual component to be labeled and then put into a list and all. So that is how I started doing things, right? So that made my life easier when I moved. Now, so when you have standard containers, the benefit here is that once you know that what size it is going to be, I can build my port facility around it. I would know how much volume my ship would be carry because every container has a specific volume. Same thing that I can build my crane facilities around it. I can build my ground transport around it so that I would know how much my weight would be carried and how much would be the time required or what would be the capacity for unloading, uploading. So standardization helped shipping industry move much faster. Today, everything shipped is into container. Nobody bothers about shipping individual item. It is always the container which are used for shipping. Okay.
So
Now,
Ashish, I get this standardization part, but what I'm not able to really understand is what challenges is this helping me overcome? I mean, what problem
Make,
is this solving? Can you relate it to some IT industry problem and
yeah,
tell me?
let's talk about that. So in IT industry, there are a lot of platform you would be using to run your application, right? Let me
Okay.
explain those concepts to you. So what you would be doing, let's say you would have multiple environment where your application would run. Development virtual machine, QS server, maybe you have a disaster recovery location, you may have a production cluster, maybe there is a developer's laptop where it is running, maybe there is a customer data center which is running. And your application, as we said, that it is not made up of one single component. It may have, let's say I am running a static website which is in Nginx, I have OpenSSL there, I have bootstrapped it, I am running a queue service which is made up of Redis, I am using a web front end which may be Ruby, Rails or software as a service or Unicorn. So that is very, very complicated for me to maintain. So I need to have maintenance done on all my hardware platform. What version of static website I am using, what is the web front end there, what are my background workers. So this is what we refer as metrics from hell. Everyone had to maintain these metrics, and always there was a challenge. Hey, the code was running fine into my QA environment, it worked on developer machine also, but when we pushed it to production it didn't work well. Why? Because there were lot many challenges or lot many differences between the application tier or other components. So that was the challenge we were trying to solve. So
Right.
container
We've
said,
seen
don't
that,
worry about all these
Ashish.
things.
So I'll just relate. So we've seen that we've built our application on a certain environment, the certain version of an operating system, and when we tried to actually go into staging and testing environment, it was a completely different environment and didn't work, right? And it really pushed our deadline. So I think this is where this will shine, right? So it will just build somewhere and make it work everywhere. Is that what you're trying to say?
Exactly. And the word I would use for that is called portability. You made
Right.
it portable in a way that it is much easier. Like physical container made it portable to ship them through a train or through a
Right.
bus or maybe through a truck or maybe through a ship. Same way, we packaged our application in a way that it become portable and now it can run on any platform wherever I want to. So that is what containerization actually brought into the picture.
Okay. So it's just one instance of that application, right? A single container.
A single you could, but probably you would need more because you want to handle the load. A single container
Right.
would have a finite capacity. Let's say it has one CPU assigned, it has 4 GB of RAM assigned. And if your
Hmm.
load is increasing, like you do auto scaling in your Amazon EC2, similarly auto scaling can happen for containers too. So you may say, I want to deploy 10 container, I want to deploy 50 containers
Right.
to handle the load. And when the load has decreased, I may bring it to 10, 5, 4, whatever I require. So that auto scaling
Okay.
feature can still be utilized here.
Got it. So you are scaling the number of containers rather than you are scaling the server uh, practically, right?
It can
So,
happen both ways. See,
okay.
container would not run on a thin air, right? Container would
Right.
still require some platform behind the scene. So let's
Hmm.
say I deployed one server who can handle 100 containers. Now I need to run 200 containers. So obviously I would need
Got
one
it.
more server. I need to run 500 container. I would need now 5 servers to handle it. So scaling
Got
would
it.
happen on the container level also, and it will happen on the server also where I am running my container. So at both level, the auto scaling would be working. Makes
Makes
sense?
sense. Right.
Good.
Is
Let's
is there
continue.
anywhere else that I can see more advantages? Is there any other
That is
in my
coming, so just
software?
wait for that.
Yeah.
We will talk about
Sure.
that. We will see that in a minute. So what is a
Sure.
container? Container is basically modeled on the success of shipping container, the physical environment. And what we do now in that container, we keep our application, whatever the code I needed. I keep any dependencies of the application like library needed to run my code, and then I put any configuration information within the container itself, and we have hooks into operating system. So it may not have complicated operating system deployed properly. It would have very thin layer of operating system who could talk to the base operating system and then start performing operation there. This is how it should be working. And what we do now, we take all of these and push it into a container. It is a self-sustainable unit. It requires operating system connection. It can make that. It requires configuration. It requires dependency. It requires your application code. all of them put together, it is like you may have a survival kit into wild where you have a way for like lighting a fire, or you have a navigation compass, or you may have a sharp knife to maybe cut something, maybe a piece of rope. So it is a self-sustainable unit which is much easier for you to maintain and move forward. So this is what a container is.
So Ashi, I have one question. Since you said one server could have multiple containers, so these containers need not be of the same application, right? So
No,
they can be different, and there is
exactly. So it
isolation between them as well.
Yeah, so there is one more layer which is called a containerization platform. I'll talk about that in a minute. So
Sure.
containerization platform takes care of ensuring that there is no a sharing of component unless you make it share, that they run in their own isolated process. Think of it. Let's say you are living into a very tall building, a very big building, right? But that does not mean that your neighbor is going to enter into your house. You still have your own apartment, and then you may communicate with them if you want to, but if you don't want, shut your door and you are isolated on your own. You don't have to worry about others. So you still are in the same building, but you have option to control who you can talk to and how you can talk to them.
Got it. Makes sense.
So talking about the platform advantages, one very basic advantage we get with container is the smaller footprint. So when we deploy a virtual machine itself contains the whole of the operating system inside it. So let's say I deployed a virtual machine. It has, let's say, Linux based operating system, and I run my application. So Linux itself will consume some amount of CPU, some amount of memory, some amount of disk space. And if I have 100 virtual machines running, all 100 of them would have their operating system which I have to maintain and patch and manage. So that makes my life miserable. Whereas containers say no problem, we would use the same operating system, and you do not have to worry about having operating system in each of the container. So I would have very small footprint. The CPU memory consumption would be very less, and they would be able to give me more power for application rather than consuming them on themselves. So that is another
So,
advantage we
so
get.
is correct to assume that containers spin up faster than virtual machines? Because I'm guessing the
Should
virtual
be.
machines have the guest operating system that also needs to start up.
Means again, I would say it depends, but in most cases, answer is yes, because there is no operating system loading. Now, you can
Okay.
create big containers also in which you are loading a lot of dependencies before it starts. So it may take time,
True.
but in most cases, I would say container would always be enough faster. Why? Because they are not worrying about the whole operating system to load, the kernel to load, and then go move forward from there. Right. So
Good.
so that is how containers are different. Containers would be having a smaller footprint. They do not have the full operating system, and they are portable, because now you could take a package or application if it was running in dev, and if you have not changed anything into the containerization layer, it can work on test, it can work on prod, or vice versa. So portability would be much easier. You do not have to maintain those basic component of application version and then component of dependency, because you packaged everything into the container of yours, and then you just ship everything as it is.
Okay. So it will behave in the same way in every environment. Is that what you're
Yes,
saying?
it
So
should. If you are
it should.
not changing anything behind the scene, like let's say we will talk about it, but let's say you have created a container for a Windows platform. So any Windows platform, this container should work. But if you take a container which was packaged for Windows platform and you try to take it and run it on Linux platform, obviously it
Hmm.
would not work, because there is some differentiation between how Windows and Linux run container. But if it was a
Right.
Windows packaged container, I move it to another Windows server and it has the same containerization layer, it should have no problem at all on that.
Yeah.
Right.
So generally, the different environments would be the same. So I believe it should work.
Yep,
Okay.
makes sense. Exactly. So we get increased portability because of that, and we are able to start then move them faster. Great efficiency and smooth scaling happens because of this particular feature, because we can start and stop them anytime I need, and I can spin up them faster, I can wind them up faster. And this goes well with our sprint based approach, or goes with DevOps approach, because we are able to start them faster, package them again, and restart them, and then maybe launch them again. So this is what some of the advantages of containers are.
Great. Makes
Make
sense.
sense?
Yeah. Now I'm just thinking, like, where does Docker come in this now? Okay. Okay, so is Docker a tool? Is Docker a platform? What is it?
Makes sense. Good question. Sometimes Docker and containers are used so interchangeably that people
Right.
feel Docker equals to container or container equals to Docker. But there is a little difference on that. Docker is a platform which is helping you to develop, ship, or run your application in a container format. But it is not the only platform. I would still don't deny that. I won't deny that it is not the most popular one. So Docker made containerization very, very popular because it was so efficiently doing it. Concept of container existed long back also. If somebody has heard about JVMs, it was Java Virtual Machine. It was in a way form of a container, not as mature as today, but in a way it was a form of a container. So same thing here. Docker made containerization very popular. It is one of a very commonly used container platform, but it is not the only container platform. There are more container platform also we could have utilized. But Docker is, I would say, a poster boy when it comes to containerization.
I get.
Makes sense.
So what does Docker exactly do? I mean, can you tell me the tasks performed by Docker or the Docker engine?
So Docker is a platform layer which you will install on top of your existing operating system. Let me go to the next slide and probably you would get answer to that. So, so traditional way of running application was that we would take physical hardware. On that hardware we'll run operating system and we will run application on top of it. That used to work for a while, but then we changed this approach. We said let's take physical server and install a hypervisor on top of it, like VMware, Hyper-V, Oracle. And once this hypervisor is ready, on top of it we would create a virtual machine, and that virtual machine will keep on functioning. Again, as I said, virtual machine would have its own challenges. So there will be complication in maintaining those virtual machine. If I have to apply patch, I have to apply patch on every single operating system. That's a challenge. So we changed it, and we had to pay a lot of money to these hypervisor vendors, and that was creating some complication. Plus, you were logged in into a hypervisor. So if you created a hypervisor layer of VMware, you could not run that on a Hyper-V or Oracle VM because they were running their own component associated with. Give me a minute. By mistake, I closed it. Let me bring it up. Now, what containerization is doing? Containerization approach says you do not need to go into the nitty-gritty details of these particular hypervisors. You could just have your traditional operating system like Windows or Linux, and on top of it, you would run a container platform. You would deploy a container platform on top of it. So Docker is one of the most commonly used container platform. It helps you to start a container, package your code, run container, then make it highly available, maybe do a health check on that. But it is not the only platform. You may have used LXT, you may have used RKT, and one very common one which is also used nowadays is called Podman. So Podman can also be a platform which you could have deployed on your traditional operating system to make it container ready. And once this is available, now you could start hosting your containers on that, and that container can be running a part of application or multiple application together. It doesn't matter at all. So what we did here in this approach of central, which is hypervisor, we basically did a hardware virtualization. We took this physical hardware, CPU, memory, disk, and we presented it into a virtual hardware format to my virtual machines. In a containerization world, what we did, we call it, in a way, it is a operating system virtualization. Your containers think that they have access to the full operating system, but technically they do not have full access. They are just accessing a layer on which they feel they can access operating system. So containerization is basically an operating system virtualization which we are utilizing.
I get it.
Are we clear?
Yeah. So and now I'm just thinking. So like Docker engine is. So when we are actually running commands to start a container, stop a container, say we are using Docker CRI, so we are actually talking to that Docker engine, right? And which is
Yeah.
actually maintaining the life
So
cycle.
Docker is a client server architecture. If I try to draw that quickly, give me a minute. Let me make little change on my settings for the drawing tablet, and I'll show you that. Give me a minute. Okay, good. Let me now show that to you. Now, what we will do, when we want to run our Docker server or Docker container, so we would need a server, and on that server we would have a Docker service running or Docker daemon running on that, right? And this
Right.
server is running Docker. That is what is also we sometimes call as a Docker agent, and that agent receives information and then it performs operation on that. Now you may run also your Docker CLI, a way to give command to this particular Docker machine on your laptop and desktop. And from there you
Right.
would say start one container or stop two container or run three container, whatever you want. And we would be then sending that information to this agent. Agent will talk to Docker service and it will say, now we got a request for performing some operation. Let's go ahead and perform that operation. So this is how the architecture of client server model would look. You would send request to Docker agent. Docker agent will relay that information to the Docker service, and Docker service would then perform the task you want it to perform.
I get it. All right. So now, say I want to spin up a container. So I need some kind of a template for that application, right? So something similar to how we have an AMI in EC2. So I guess it's called a container image, if I'm correct.
Yes.
So
So best
yeah.
would be that I explain to you first that how AWS uses these terms or what AWS
Yes.
terminologies is. And there is a question from Anupama, what is the relation between container and a pod? So we'll discuss that in part of EKS. So just let me explain first that how AWS facilitates running container. So concept of container hopefully is clear to you, Parna. Let's see now
Yes.
how AWS can help you. So I would divide container services in AWS into two categories. One is called image storage, and second I would call a compute. Image storage is you want to perform task 1, task 2, task 3, task 4 in a container. So what you would do, you would package all of these information into a Docker image or a container image. That image has everything which is required to run that application, the libraries, the binaries, the hooks into operating system, maybe a writable volume, and this image is what I have to store somewhere. Like you had your EC2 machine to start, and how a EC2 machine is started, you would need an AMI to
Right.
start your EC2 machine. Same way you want to start a container, how you would start a container, you would need a image for it to get started. And as AMIs are stored into EC2, our images are stored into a very specific component which we call as a Amazon ECR. So ECR would help me in getting my containers ready, and once I have it, I would be storing my images into this particular service which is called Amazon Elastic Container Registry or ECR. It is a repository.
So it's similar to Docker Hub, are you saying?
Exactly. Docker Hub is more on a public domain, whereas this can be within your account and you have full control on who can publish into it, what they can access and what they cannot access. So it gives you more private, similar method of something which is in Docker Hub, but this is
Okay.
what you are deploying within your own environment. And it has durability and then IAM permission and then
Okay.
integration with your CloudTrail. So that has gives you more visibility on what is actually happening within your environment.
Okay, so you're saying I can control who can actually go and access those images using IAM roles and
Exactly.
permissions.
Yeah. So see, I am integrated with almost every service in AWS. So if you are going and say I want to push an image or I want to read an
Hmm.
image, I would have no problem at all into running these things.
And great. And you did say that there is traceability even in CloudTrail. So I can go
Yeah.
and look at my audit trail and see who has actually pulled that
Who has
image as well.
actually used or which particular service has utilized or what particular role has accessed it. So yes, we can do that. Right.
That's
So we
great.
could utilize that. So what we have as a service is called ECR, Elastic Container Registry. And like if you know about Amazon S3, in S3 you create buckets. In bucket you create objects, right? So similarly, in Elastic Container Registry, first you create is a repository. So you control access to people or maybe some setting or configuration on a repository level. I may have a repository for my Java code, I may have a repository for something else, and once it is ready, then I keep my container images on that. So images are not directly stored, images are stored into a repository, and repositories are created into a service which is called ECR.
I believe this will have version control as well. So obviously my application will evolve over time. So this will maintain that
Yes.
too.
So yeah, means if it is a code would always need a version control because you would keep on
Right.
updating a code. So your Docker image, technically speaking, it is just some line of code. So we would be maintaining multiple version of your image based on what you changed. So you updated something, you modified something. So that would reflect into your environment too, should not be issue.
Great.
Now, this is the image. It is like having a disk, but that disk has to be connected somewhere so that I would be able to perform operations on that. So once I have an image, I may want to run it, and for running it, I would be needing CPU, memory, disk space and all. So what we would do here, I would need a compute platform to run my images, and that compute platform can be provided by EC2 or it can be provided to you in a serverless fashion where you don't maintain any of the component. So if you feel I want more control, I want to see how much size of the image, so how much would be the EC2 instance size, what type of operating system will be installed, what would be the configuration within operating system, I will go with this approach, which is EC2 hosted. But if I say I have a container, I want to run 5 copies of that and I don't worry about at all anything beyond that. So that I would be going forward with my, sorry, I closed it by mistake again. So coming back, so I could say I just want to run a container and I don't care that how is the server providing me the resources. So I could just say I have this container, run 10 copies for me. It will require 1 CPU, it would require 2 GB of RAM, and this serverless service would take care of deploying every infrastructure for you. So the serverless service we offer is called AWS Fargate. So
This is
Fargate is
similar to
our
Lambda,
way.
Ashish? Is this
Sorry.
something similar to Lambda?
Similar in the sense, yes, but Lambda has some limitation. Like Lambda has a limitation where you would be able to run only for 15 minutes, right? Or there is a
Right.
size limitation that how much would be the container image. So Lambda can be one way of running container, but then you have limitation of what Lambda imposes on it. If you are bogged down by that, then probably you will go for serverless service Fargate. In a operation model, it is same in the sense that you do not have to maintain anything behind the scene. You just tell us what you need and we would take care of creating that component and running it, maybe providing it network connectivity, maybe providing a security, role, association, log collection. We will take care of everything for that. So that is a serverless way of running container, that is through Fargate.
I just thought of few other things because we are using lambdas because I think in Fargate you can specify the amount of compute, right, which you cannot do in
Yes,
case of lambda.
exactly.
And
Good
cold
point.
starts, cold starts. I guess here the server is running all the time. Is that my
Yeah,
understanding
here
is
the
right?
servers are always running, and when you say I want to launch my container, that is put together into a task or into a pod format. So we'll discuss that. But yes, you are
Sure.
right. Here I have control on how much CPU I want to allocate, how much memory I want to allocate, and if I want to combine two of the containers together. So those type of thing I can do when I'm running Fargate based application.
Got it.
So Fargate is a good choice when you don't want to get into hassle of maintaining your servers. But sometimes it may be possibility that hey, I am using a third party software and I need operating system level control on the server where my EC2s, where my containers would run. So what you could do, you could take some EC2 machine of your choice, install Docker platform, install a networking software on that, connect them together, and you can create your own self-provisioned cluster on EC2 instances. So you would take a EC2 with a supported operating system, install Docker, install all dependency, configure networking, configuring clustering, and now you could go ahead and then have your cluster running on Amazon EC2. That is another choice. If you need server level control, probably this would be a better choice to you to go for. So AWS will still take care of physical infrastructure, but you are responsible for any version of Docker you want to run, which version of networking you want to run, which services you want to keep. That is giving you the control you are looking for.
So I have a question, Ashish. So I can choose the type instance types as well that I
This
want.
is your cluster, right? So you
Okay.
decide what you need. You could say I need 10 of C5, I need 5 of C4, no problem. You could go ahead and do that. That is your cluster. You decide what works best for you.
So when you say a cluster, you mean a group of EC2 instances which are running containers, right?
Yes, because it will make sense. Let's say you have run only one EC2 container, EC2 instance. So this is only one EC2 instance running, and I have started running multiple containers on top of it. Now, there would be limit of how much physically this EC2 instance can run. Can it run 10 container, 100 container, 500? So most of the time you would create things into this format, because if this fails, all my containers will also be down. So I may configure it into a way that if this server goes down, we perform health check and we restart those container on a healthy server which is running within your environment. So it is always suggestible to put them into a cluster mode.
So this number of EC2 instance, is it fixed, or do we have things like auto scaling how we have in EC2 deployment over here as well,
See, this
which
is your
can
cluster.
automatically grow?
This is your cluster, so you decide whether you need auto scaling or not. But yes, it is a
Okay.
EC2, base unit is EC2. So all the component of EC2 like role assumption and the networking, VPC, and then auto scaling would still apply on it. So that should not be a problem at all.
Got it.
Okay, good. All right. Now, this is one way, but the challenge here is I have to take care of installation, operating system, I have to take care of network connection, I have to take care of health check, I have to take care of placement. That can be complicated. I don't want to get involved in this day-to-day operation. So AWS says, don't worry, we'll take care of these things for you, and we will give you a managed service which is called Amazon Elastic Container Service, or called ECS. So ECS is a managed platform on which you can run your container without worrying about which operating system I would select, or which version of Docker platform I would be needing, what networking configuration would be, how the cluster would be formed. So that is what ECS allows you to do. Right.
So
So
Ashish, does ECS support only Docker, or does it support other containerization engines like you mentioned?
No, it is right now, it is only Docker as what we support in that. So what we deploy for you is Docker. If you need that kind of flexibility of selecting your own engine, probably then self-provisioned cluster is a better choice for you, because then you can select whatever you prefer on that.
I get it.
Now, one common service this uses is this run container using fully managed container orchestration service. I will talk about orchestration in a minute, what is orchestration, but we have one more service which is called EKS, Elastic Container Service, and this service also allows you to run, but if you have heard about Kubernetes, a lot of companies want to use Kubernetes, they could have used EKS as a service. ECS and EKS, they both are orchestration service. So some common thing they take care of is, let's say, starting off a container. So let's assume that you have so many servers which are making up your container platform, the base platform. Now you want to run a container. So should this container be placed here in this machine, or here, or here, or here? Do we have sufficient capacity or not? So that provisioning of container, depending on the configuration you defined, let's say this machine has only 2 GB free RAM, this one is 4, this one is 2, this one is 8 GB. My container requires 3 GB RAM. So I don't want to manually say you cannot be run here, you cannot be run here. This service, orchestration service, would take care of placement of my container, where my container should be started. So it will be all done by your placement engine which is running as orchestration, right?
So
Then
I can
it may
configure this, Ashish. So I can make up a strategy that I want only one container of every service on each instance, or I want 2 containers of every. I can do that as well. Can
yes,
I
so you have
manipulate that?
control on that. Like one common control customer want to do is like, hey, this is running in AZ-A and this is running in AZ-B.
Right.
So I want to run my service in a manner that not all of the component run in one AZ, because if it fails, my service would be down. So I have a strategy to distribute my load when it starts. So yes, that is in your control. There are multiple methods of that, but yes, that is a control which you get with this service.
Right. And I guess if I want to save cost, I might want to actually stuff all my containers as much as possible into an instance also. I can do those as
See,
well, right?
in these services, like if I'm talking just purely for ECS, you pay for the infra you run it on that. So you started a EC2 machine which has 4 CPU. So we will charge you only for this machine. Now on this machine you run 10 containers or 1 container or 10,000 containers if you can fit in, we don't mind. We provided you EC2 and then you use it in the way you want. We don't charge you on a container level or a task level or a particular load group level. So we do not worry about that. We just charge you on the server size. Whatever server is, you just keep on running that.
I guess this is how it will be different from Fargate, because I think here, whatever is the size of the CPU, you are paying for that, right? Whereas
Exactly.
in Fargate, it will, I think, scale automatically, right, based on
See,
uh,
scaling would still be, you would define the parameter for scaling. Let's say I want to
okay,
scale when the
maximum.
load increases. So you would create it, but here you will pay. Let's say you had a task which was running only one container. So in Fargate, I am paying for that. It scaled and it started running 10 containers. So now I am paying for 10. It scaled back and now it is running 2 containers. So I am paying for that. So here I am paying for the actual utilization of my service rather than the infrastructure. In ECS, EKS, I am paying the infrastructure cost. My server runs with 10 CPU capacity. Even if I am running no containers at all, I am still paying for 10 server capacity. So it depends
I
on
get
what use cases you have.
makes
Be
sense.
clear on that?
Okay. Yeah, but I'm now that you told me that there are two services, ECS and EKS, I'm a little confused. Both of them do orchestration. When you say orchestration, do you mean managing multiple containers? Is what you call as
It can be
orchestration?
one part of orchestration. So first thing, this service will take care of your placement of container, where to start this container depending on memory and CPU constraint you define. Then it will take care of scaling them up and scaling them down. So you could say, based on the CPU load or based on number of requests coming to my load balancer, I want to add more capacity in terms of more containers, or I could say I want to have more capacity in terms of EC2s. So this is my cluster. Cluster is made up of Amazon EC2 instances. These are all my EC2s, and on top of EC2, I run my container based services. So this orchestration services can scale your container or can scale your data plane also, where your actual containers are running. So you decide what type of scaling you need, and the service would take care of those components. And then if something fails, now let's say if one of the node failed, how many container got affected, what is my desired
Yeah,
state, how many container I still again start or I have to restart, that will be all taken care by the service itself.
got it. Okay. Now that brings me to my next question. Now that we have two orchestration services, how do I decide which to pick? I mean, there is ECS also, there's EKS also.
I, I,
How
I
do I
would go with
decide?
my favorite answer, it depends. It depends on multiple factor. So most of the time what we have seen customer making the decision is based on their existing skills or the type of workload. Consider that ECS is a very easy way to get started, right? But it may not have a rich ecosystem of services like Kubernetes. So here you have engine choices, you have choices of monitoring platform, you have choices for log collection, you have choices for maybe security, you have choices for networking. So this one is more open source. Actually, Google started building this type of cluster and then made it open source, which became Kubernetes. So it has very rich ecosystem, but it is little complicated. Again, complications definition can vary, but I would still say maintaining a EKS cluster is very complicated, whereas ECS is not having that many moving components, so maintaining it and running it would be much easier for you. So if
Right.
your team already has skills or you have very specific use case, let's say a simple example, hey, I want to use Prometheus for my monitoring. Now I may not use Prometheus with ECS because I do not get that type of control. Then I have to go for EKS as a service because I have a rich ecosystem of Kubernetes and I can include Prometheus monitoring inside it. So it will depend on what your use case is. You need lots of feature, lots of requirements business is putting into. You need an ecosystem for monitoring and log collection and then distribution and all. Probably your choice will be a better for Kubernetes. If your workloads are not that complicated, you don't have expertise in the team, or you don't want to go into the rabbit hole of Kubernetes, probably I would say go for this.
You're
Makes
right.
sense?
So I've seen amongst our competitors also. So there's an enterprise organization who have a dedicated platform engineering team, and they have a service SRE team who are tenured engineered who know how to manage. For them, I think going for EKS would be better. Whereas I know of startups who are just starting to containerize their application and they want a simple way to do it. And
Exactly.
I believe ECS integrates very easily with services like load balancers, auto scaling, and all, right? So I think
Yeah, I agree.
for
Means
those
ECS is like easy. Let's say both are
easier
car,
to
right?
Yeah.
One car which is giving you the speed and has lot many feature, but its maintenance is very very high. Another car,
True.
like sometimes people say that Japanese car are good and German cars are also good, but German cars maintenance cost is much higher than a Japanese car. So it depends. So here in Kubernetes there are lot many moving parts that gives you flexibility, but that would also mean that you need to have a complicated way of managing it, maintaining it. Consider that when you buy a simple car, on its dashboard there may be 5, 10, 15 buttons. You buy a car which is complicated, it may have 50 buttons on top of it. Both are
True.
car, but they have different choice and options available to you.
True. I get it.
So
And
the
yeah.
question, EKS, Elizabeth, yes, EKS offers full control over your cluster because you are deciding which version of Kubernetes and what kind of components you need, what third-party components you need. So yes, there is a thing, and yes, one size fits all. So that is a good thing. Now, you asked about why containerization. Let me answer that. So just one container on a platform is okay, you can maintain it. But when you have to run thousands of container, then it can be very complicated thing. And that's why you need a latter approach which will help you to orchestrate. So orchestration helps you with placement, helps you with health check, helps you with the monitoring component, helps you with the starting component, help you with the load balancing component. That is all done by the health check, by the orchestration services. So saying it again, your services like ECS and EKS, they are still running on EC2. What they are doing, they are providing you the orchestration for maintaining and running container, but behind the scene it is still Amazon EC2 which is providing the CPU and memory power to it. Here it is your responsibility to maintain it, and here it is responsibility of AWS to maintain it. It is still behind the scene EC2, but this is much easier for you to start and stop rather than maintaining the whole cluster on your own.
I get it. Ashish, would it be possible for you to give me a differentiation between, uh, when you deploy an application on a EC2 versus deploying a container on, say, ECS and EKS? How do they differ? I mean,
Yep.
can you give me a breakup of that, the process?
Why not? And this would be a good way, so that I would put it like that concepts do not change. The way they are implemented changes. So I would try to relate some concept of EC2 with our containerization services, and that would give me an option to also talk about pod and then services and tasks. So let
Yes.
me go ahead and talk about it. Let me first talk about how EC2s are operating, and hopefully everyone knows about it. So when I have to operate or deploy EC2 machine, what I need a starting point. That would be my AMI. AMI is the image on which we have stored all the configuration, operating system data, and from there it starts. So AMI is stored there. Where is AMI stored? Though we don't see that bucket, but behind the scene, the storage we provide for AMI is Amazon S3. So everything behind the scene is stored into Amazon S3, right? So this
Right.
is an image. This image is not a running copy. So if I want this image to be a running copy, I have to tell and launch an instance. So in an instance, when I launch, I say which AMI to use, how much CPU and memory I would allocate, what role I would be assigning, which VPC it would go into, what storage I would be connecting. Now it is a running copy. So an instance is a running copy of a AMI. AMI is a static component, instance is a dynamic component, think like that. Okay. Now,
Okay.
one instance may not be sufficient to handle everything, or if this fails, there would be issues. So what we mostly do to maintain service availability, we put them into a auto scaling group. So when I say auto scaling group, it is still a definition. In an auto scaling group, I say which instance to use, what minimum maximum configuration would be, what would be the health check associated, what would be my deployment model associated. So all of that is put together into something called an auto scaling group. Are we clear till this point?
Yes. Yes.
Now, auto scaling, if you look at it, is still a definition. It is not actually having any memory or CPU allocated. So what we do, this auto scaling group, whenever you say start with minimum 4 or 5 or 7, whatever you say, we push that information into an execution environment, and that execution environment in most cases nowadays is Nitro. So Nitro is our purpose-built hardware-software combination which allows us to run Amazon EC2 machine. So when you say I want to launch 10 EC2 machine, We go to Nitro system, find out which server has sufficient capacity which are available, and then we start launching your machines there. And that is where your auto scaling group would have multiple machines running on that. And obviously, you can launch multiple auto scaling group depending on your business, depending on the application type. And as these are independent component, like multiple members in your team, you would need a front end for that. That would be a load balancer, and your users would be connecting to a load balancer, and through that, they would be accessing the application which is deployed on your Amazon EC2 machine. This is what a way of EC2 working. Any questions here?
Makes sense. No, makes sense.
Good. Now, concept remains same, so I'll try to relate as it is. Like for EC2, we started with a AMI in containers. When I am deploying with this ECS, I have to say it differently because ECS wording is different and in EKS wordings are different, but exactly the same components are used. Let's go ahead and see that. So instead of starting from a AMI, we start our containerization journey from a container image. Where is container image stored? Storage for the container image is provided by our service which we call Amazon ECR. This container image is still a static file. I want it to become a ready to use component, and for that I would be running that as a task. So task is a very specific terminology we use in Amazon ECS. What a task is, task has mention of which image to use, how much CPU and memory to allocate, what role it would be using, what would be the networking and storage configuration associated. So that setting is what we refer as a task, or in technical word we call it task definition. So task definition
Ashish,
tells me
I
which
have
container
a
to use.
question.
Yeah.
So which container? So do you mean that every task can have only one container, or can it have more than one container?
It can have more than one. Most of the time it is one-to-one mapping, but if you want, what can be use cases? Let me explain that. So let's say you deployed a task in which you have started only one web server container. Now your boss says, hey, we also need to have log collection. So one option is I could push one more container and create a new version of task which will perform a log collection of that. So a task can have one container, which is most of the time is true, but if required, you could have multiple containers within that also, should not be a problem.
Okay, so is this what we call as sidecars?
It could be sidecar. That is what one reference, but there are other ways also on that. So sidecar is basically like if you have a two-wheeler, in a two-wheeler there is a main vehicle and then you put a sidecar associated with that, right? So that is in a way sidecar. So this main functionality is here, but it has a pillion which is allowing us to perform, maybe performing encryption or log collection or security or maybe analysis, whatever it is.
I got it. Okay.
Now, so the task is still one single container image running, or maybe multiple container in that, or a one section of it. This is the minimum unit you start with, but a task can fail and then your application would come to standstill. So what we would use here, we would be using the service, which is the component we are calling it. So task is combined into a service. In a service, we say how many tasks to start, what would be the minimum and maximum associated with that, how I will perform health check, what would be my deployment option, and that all is called a service. So service is still a definition, and that service need to get executed. For that I need an execution environment, and that execution environment will be provided by either a ECS cluster or it will be provided to me by Fargate. So I create my support service definition and then say service, I want you to run on cluster number 1 and this many copies are required. So service would get started there, or I could say service, I want you to run on Fargate and the service would be started there. As it is multiple component, we would still use a front-ending load balancer by which my users would be connecting to these particular services which we have launched.
So over here, Ashish, when you say service, so say I've broken down a monolith and containerized it and broken it down into multiple services. So when you say over here service,
that should be the most approachable thing, or should be suggestible thing. So you take your bigger monolith and then break it down into multiple services, and each service can have its own functionality. Let me give an example. So let's say if you have built a monolith application, and in that monolith you have options or component which is for login functionality. Let me write down. So you have login functionality, you have then registration functionality, then you may have, let's say, sales functionality on that, maybe you have payment functionality on that. Now with monolith challenges, it is running on a server, and now you are saying that we are running a campaign and we have to have more registration coming to our website. But in monolith, when you increase capacity of your server, it is increasing capacity of the whole monolith. But when I'm talking about microservice architecture, login is single service, registration is a single service, sales is a single service, payment is a single service. So I could say I am running a campaign where a lot of people will be performing registration and they will be then logging in after. So let me increase capacity only for these two services. I don't expect them all to buy sales, so I would increase this by 30% capacity, but sales I would increase you only by 5%, and payment I would increase you only by 2%. So this kind of flexibility I am getting, that how I am able to scale these component if the need be. Does
So
it
by
make sense?
scale, you mean like the number of tasks. So say your
Number of
registration
tasks in that,
requires
exactly.
multiple tasks because it requires a huge number of registrations, whereas your login component may not require that much
That much
scalability.
of
So
it.
it can do with a smaller number of tasks. That is
Smaller
what you
number of it.
mentioned. Okay,
Yep, exactly.
great.
So if I draw how it the packaging is, so you have service which you mostly interact with. What a service would be made up of, let me use a different color here. A service would be made up of tasks inside it. So like these are my task 1 and task 2. Let me write it down, task 1 and task 2. And what a task would be made up of, a task would be made up of multiple container or one container within that. So this is what obfuscation would look like. Service which is made up of task which is made up of containers. Make sense?
Makes sense. Yeah.
Good.
And these
All right.
tasks could be on individual instances, or they could be on the same instance as well, right?
Your decision,
That's our
so
decision.
you
Okay,
decide that whether it should be on different, distributed differently, or should be on that. Let me do one thing. Let me quickly go into console and spin up a ECS cluster, and we should be able to see all these things. So let me bring up a cluster, let's say in Ireland. We will set it up, and cloud makes this thing so easy. Setting up clusters on your own into physical world is always complicated, versioning and then compatibility and all. But here maybe in 5 minutes I would be able to get started. So I am in ECS service here, Elastic Container Service. I do not have any cluster started. What I could do, I could say create a cluster. So in a cluster, I would give it a name. Let's say I'm calling it ECS cluster 01. I would select where my cluster is provisioned for. Is it Fargate, serverless fashion? Now I am saying no, I look for Amazon EC2 only. So here if you see, do you want to use a auto scaling group or you want to use existing auto scaling group? I could say I want to use a new auto scaling group. Do I want to include on demand instances or spot instances? So I'm saying I just need on demand instances. Which Linux version you are looking for? Select whatever is your requirement. Select what type of instances you want. So let's say I go for C1 dot extra large, or maybe I go for C5 dot extra large or 2 extra large on that. So this is what I am looking for, C5 dot 2 extra large. Let me go for that. So C5.2 extra large, which will give me 8 CPU and 16 GB. What role to assign? Minimum desired capacity, I could say I need 2 to get started. Maximum, I will scale my instances up to 8, but nothing beyond it. So this is auto scaling I am configuring on instance level. Then I configure networking. So I have to select a VPC, select the subnet on which my cluster would be created, because behind the scene it is EC2. So EC2 would always require you to have a VPC subnet selected, a security group selected as I am selecting it here, use an existing security group, assignment of IP and all these, and then I say create. So now what happens behind the scene, a cloud formation template kicks in, and that cloud formation template would go ahead, create auto scaling group, create 2 EC2 instances for me, and then make it ready for my consumption. So if I come back to cloud formation, here I could see it has started spinning up a launch template, a cluster in a auto scaling group, and in some time my cluster would become ready. So what I'm doing here right now, I am setting up this component which is my ECS cluster, and once it is ready, I would then use tasks or services to run on top of it. Does
got
it
it.
make
So in
sense?
each cluster, I can have multiple services, and in each
Exactly. We
service,
will do
I can
that in
have
a minute.
multiple
So we'll do
tasks.
that. So question Anuradha is having, what is the OS used by ECS? So we saw that we could have selected any Linux operating system or any type of operating system which is provided here. So when I was creating this cluster, there was an option to select what my operating system requirements are. So here I selected I want on Amazon EC2. As soon as I selected it, I had an option to select which Amazon Linux version I need. Do I need Bottle Rocket? Do I need Windows Server? So you decide what operating system you want on your cluster here. Shouldn't be an issue. So let that cluster spin up. In a minute or so, it would be ready. So currently those services running, 2 instances running on top of it. That is into auto scaling group. And if I go here, this cluster has been created successfully. I could verify that CloudFormation has spin up my EC2 instances. If I check resources, it has created my cluster and auto scaling group is ready. So if I go and check on my EC2 console, I should have 2 instances getting started because I said I need minimum 2 instances to always run for me. So here I may have more instances, but let's see how many are running right now. Running are 2, and they are cluster 01 instance, cluster 01 instances. Both instances are C5 2 extra large, and if you look here, it has automatically spin them at across availability zone. So even if one of them fail, your cluster would not be completely down. It can still survive from another availability zone. So this is how it has created. If I had 3 instances, probably it
Ashish,
would
you had
have gone into
mentioned
1A.
you had mentioned minimum as 2 instances. That's why 2 have spun up, right?
That's all. That's all. And
yeah.
I have already said auto scaling. So if needed, it would go ahead and add more instances up to 8 because that's what I configured as a maximum on that.
Okay. Okay. But that we have not still configured, right? How to scale up, that is still to be done.
That parameter by default is CPU, but I can have different parameter for scaling event that we could do.
Got it. Okay.
Good. So this is what my instances started. My cluster is spinning up. Now let's talk about task definition. See the name, it says task definition. It is a configuration which I am specifying. So let's say I want to create a new task definition, and this time I want to run a front end web server. So I'm giving it a name front end, and web server 01, or let me call it front end web server task. I have to specify where you intend to run this task. So we could have selected Fargate. I could have selected Amazon EC2 instances if the need be. So I could have selected this Amazon EC2 instances on that. Now a question here, while selecting OS, is it necessary that we need to select container optimized image for OS or EC2? It does not matter. See, the image list which we have given there, it is already optimized instances. If you feel you need more control, then in this case, Pradeep, you have to select the EC2 mode. You deploy EC2, install your own operating system, fine tune it and install Docker. But here it is already optimized image which is given to you. So I selected EC2 instance, I selected my operating system, I have networking mode. This is a longer discussion. So right now I will go to bridge just to explain what a bridge mode of networking is. That if this is my EC2 instance here, I would have my container running on top of it. When I say bridge mode of networking, bridge is like this. So I said port 80 on instance if receives traffic, I want to forward to port 80 on my container directly. So that is called bridge mode, but we have more modes which is called VPC, which is commonly recommended, but it would require more details. So I'm not going for it. I'm just going for bridge. Now see
So
this.
it's mapping the host port to the container port, right? That's
exactly. So bridge, what is the bridge doing? It is connecting one part of the island to another part of the island. So that is what a bridge is doing. Same thing, we have host which is coming on receiving traffic on 80 and say forward it to 80 on the container. So that's what a bridge is doing. Okay. Now see this, this is important. Here I am specifying a task size. What I mean by task size. So I go ahead and say, hey, I want a task which would have 1 CPU and 3 GB of RAM. That's what I'm specifying. Obviously, I could go into much smaller unit also if I need to. So I could go into 0.25 CPU and all. So this is the task level. And a task would then further have its own containers, right? If you remember, so task would have its own container. They would be limited to total memory which we have associated or CPU associated at the task level. And now I can say container 1, you will use 0.5 CPU. Container 2, you would be using also 0.5 CPU. So this kind of bifurcation can also be created, should not be a problem at all. All right.
Okay.
So let's go ahead and do this. So I selected a role. I'm not needing a role. I don't want this task to go and talk to someone else. I say 1 GB RAM
So,
is good enough, 1
Ashish, so
CPU and 1
just
GB.
stopping you right there. So, when you say task role, does this mean if my container needs to talk to, say, a database service or S3, so it needs
Could be
permission? So, are you
anything.
talking about that role? Are you talking
Yes,
about
so like
task
for
role?
an instance, you need a role so that it can talk to a Lambda or a S3
Hmm.
bucket or a DynamoDB table. Same, my task can be assigned a role, so it would empower the task to talk to the backend instance and then perform operations there.
Okay, similar to an instance profile, you would say.
Exactly,
Okay.
exactly. That's the right wording, instance profile. So here, now we were asking that there can be placement constraint for tasks. So yes, we could do that. So we can say this task should run on XYZ servers only. It should not connect with others and all these type of things. So constraint and see this. I defined the task and now I say which container would be within the task. If I want one container to run, I could. If I want more container to run within the same task, I could have done that too. There is no limit on that. I am keeping it simple. I am just using one essential container. So see, this one container is always required, but you can add more container within the same task if the need arises for you. So I removed it and
Ashish,
now I
just
said,
one more thing. So this we are doing it through the console, but on a regular basis, if I want to automate it
probably you
and
will
make it
not
simple,
come to
I could,
console.
yeah, I would be
Yeah.
using a config file. I guess there should be something in JSON or YAML. Is that an option?
Yes, so most of the time when you are deploying it for production or through CI/CD pipeline or through DevOps, you would have a configuration file through which you will deploy everything. So those
Okay.
files are into JSON format. Those are called task definition file, and through that you would perform all these operations which I am doing from UI.
Okay. So behind the scene, it's actually doing that, but we are just doing it through the console.
Everything as a API in the AWS. So whatever you are doing from front end is actually being translated into an API call behind the scene.
I get it. Makes sense.
Now let me run my web server container here. I'm just calling it a web server. And now I have to say from where my image would come from. So this image can come from a public registry. So if I just say I need HTTPD image and latest, basically I am referencing it as from a Docker public registry. If you feel no, I want to provide my own image here, which I have stored in ECR. So I would provide that path of the image, and then when container starts, it will pull the image from my repository and then get started from there. So that is what we could do. So I am just using a public image. I have not created any of the repository. So I'm just using ECS as a service. And here I say port mapping. If host receives traffic on port 80, forward it to container port 80, because this HTTPD is by default running on 80, and one container can have multiple port mapping also, should not be a problem, right? So we created this, and once I'm happy, I could have allocation done on the container level. So see this, remember this, on a task I said, task I am going to give you 1 CPU and 1 GB of RAM, and within the task I can say container I am going to give you a 0.5 CPU and I am going to give you a 0.5 GB of RAM. That's what I can do. So that I am putting it here. That's what we have. And we can have environment variable also, where we can have database connection string, username, password to talk to other services. Log collection can happen. I'm not interested in log collection, let's say, as of now. Once I'm happy, I would say create a task. It is still a definition. It is not running. I am creating that in isolation first. And once my task is ready, I could then deploy that task, and where the deployment will happen, I could deploy it on a cluster itself. So let's go to cluster now. I will come to cluster. My cluster is ready. If I go into details of it, it will tell me clearly what it is made up of. Its infrastructure is made up of these two instances, which are EC2s. Is it running anything right now? Answer is no, it is not running any task at all. Is it running any service? Obviously no, nothing is running as of now. What we can do, I could just start one single task if the need be, right? So I'm running it a new task. I say I want to run a task, and which type of task I want to run, I could have selected here based on my launch type and capacity provider, and see these are the tasks which I have. So my was front-end web server task, which I am selecting. If I had a version, it would be selected here. By default, it is latest. And I am saying how many of them I need. I say I need one only. So I selected one, and now placement strategies are there. All settings are there. And I would say, okay, let's go ahead and create this task. So now this particular image information which I provided is being deployed on the cluster which I have. So if you see here, my cluster has started provisioning this task which is into pending state, and as it is a smaller image, doesn't have full operating system, it came into running state as it is, as you could clearly see. So on one of these servers which I had my infrastructure, my task has been placed. Let me close all these and we will see. So right now my task is made up of what? One container. This is the container which is running HTTP latest image, and that has been put together onto a network binding which is port 80 of host coming to container port 80, and this is the IP address of my EC2 machine. I'm trying to connect to its port 80 if you see here, and if everything is fine, it should display me a simple page which is coming directly from the container from which I am running the task. Are you clear on
So
this?
Ashish, I have a question over here. So over here, we did not create services, so I can just directly run my tasks in the cluster
See,
as well, right? It's
let's
because
go
this is a
back to
simple.
what I explained in terms of EC2 machines, right? So you could run one EC2 instance, which is one task, or you could say, no, let me put it into auto scaling and that will become your service. So let me show the service component also. So I come here and now I say,
So
okay,
Ashish,
task is
sorry,
fine.
I have one more question. So when we did not go and say what's our task placement, so it randomly picked out one of the instances
It's a
and put
default
it there, right?
placement. Default is
Okay,
AZ balanced. So this one
okay,
was started on one. If I start another task, hopefully it would go into the second task, into second
okay,
node. So you could utilize those things, should not be an issue.
okay,
Now I go for services and say service, let me create you. So in service, what I have to specify, in the service I have to say, hey, I would be running it on a cluster. Fine, I am running a service, not a task. What I would use as a starting point, I would use this task. And now if you see, I am giving it a name, let me call it my web server service. It is no longer a task, and I say I want to create a replica and I want 4 copies of that, or let's say 2 copies of that. So now this service would make up of 2 specific component in that, 2 tasks in that, and once I am happy, I could select again capabilities of load balancer where these tasks will be placed. So default is here AZ balanced, but you have more options here: bin pack, one task per host, random selection, custom selection. So you could have
okay,
selected any placement strategy for it. If you want to mount a volume like a disk, that can also be done. You may attach to this particularly machine EC2 deployment and all that, sorry, EFS node, that can be done. And now I say let me create this service. So once the service starts, what it would do, service would itself contain 2 tasks. Why? Because I have provided that configuration. So now auto scaling can happen on service level, or auto scaling can happen on the EC2 level, which we have configured while we were defining the cluster, right? So this is my service, and in some time, as you could see, it is running currently 0 of the 2 tasks running, but in some time, if everything is fine, now this will create a problem. Why? If you remember, my networking was 80 to 80. So 80 port has already been consumed by
in
one of my
conflict.
existing node. So that's why only on one node I would be able to have one container running, but it will not go to the full capacity because the port 80 has already been consumed. So for these kind of situation, we use Amazon VPC networking, but it is beyond little discussion point in this particular demo.
So Ashish, another question. So over here we said we want 2 replicas or 2 tasks. So will it by default, like you said, it will place it on each of the instances, 1 task each, right? That's the default,
Yeah,
unless I go and specify that
unless
I
I go
want
and
them both.
specify these things.
Okay.
Now if you look here, my task failed. Why? Because I do not have port number 80 available at all. So one option for me is that I could go ahead and say, hey, okay, let me stop this particular task which I started 4 minutes ago. So I'm stopping it all, and then once I stop all tasks here, I could then start launching my service again, and then probably it would work fine. It should have no issues at all. My service would then keep on providing some information. It will be failed. Obviously it has failed right now, and I can go ahead and say let me update my service, and then I could provide some more information. So let's say now I want to have only one task in that. Done. I can update, and now my service would again start launching one task for me. So that's how it will be running. Now in the interest of time, I want to quickly talk about Kubernetes, that how Kubernetes will work, what will happen in that case. So Kubernetes is not very different. When you run Kubernetes, the main motivation for customers could be that they want to run an open source platform, they want more plugins to do. But in Kubernetes, two concepts are there. One is called control plane and one is called a data plane. The analogy I use for that, if you go to a movie or this orchestras, there would be a conductor who would tell when the violin will play or when the guitar would play or when a trumpet would blow. All of this is controlled by this person. He is not playing music himself, but he is directing others to play the music. That is what your data plane is.
So is
So
it like a
control plane,
management? Is like a
this is a
management
management
layer,
platform.
worker layer?
This is a management layer. This is a brain, and this one is your hand. So brain says to hand, go ahead and scratch here or go ahead and pick up a pen. Hand cannot decide on picking up a pen unless brain says to it. So that is a control plane, and this is a data plane which is happening here, right? So that's how your control plane and data plane work. So when you say run a container, your request goes to control plane. Control plane will then tell to data plane, hey, I have this request, please fulfill it. And then your container would be running here in this case needed, right? Now, just in the interest of easy time, I would say same concept. What we discussed in ECS also deploy or also apply on EKS node also. Let me explain that. So we still would have a container image to start with. Container image would be still stored on ECR, but instead of calling that as a task in Kubernetes world, we call it pod. So pod is still a definition in which I said how many containers to run. So the base unit in Kubernetes world is called a pod. So we start with a pod. Once a pod is ready, it can work independently, but probably it will fail and my service will be down. So what we do, we combine multiple pod into something called a deployment. So deployment is a group of pod you could relate to ECS service. ECS, what we used to call service in Kubernetes, we would be calling it as a deployment, right? And then here, as I was running my service on a ECS cluster or Fargate, in EKS, I could run it on a EKS cluster or I could run it on a Fargate. Here deployment is running here, and we use a very specific word. When you front end a deployment with the load balancer, that is what we call in Kubernetes world as a service. So your container image is packaged into a pod. Pods are packaged into deployment, and when pods are deployed and front-ended with the load balancer, that is referred as a service, but the concept is exactly same, only the naming and wording is different, but same. Talk about EC2, there we call auto scaling group, here we call it a service, and in Kubernetes we call it a deployment.
Just another thing. So for task, we have task definition. So I guess for pod, we'll have manifest files, right?
So pod is again, it's a definition. We call it manifest in this case, but it is again a JSON document or a YAML document, and you have written what exactly you need, how much CPU you need, how much memory you need, which
So
container will be part of.
Definition.
Exact same thing as task, but in a different method. This is called manifest file.
Makes sense.
Good. So I think we have hit the time limit. We did not have time today to discuss about the question answer Purna, so that is hopefully still able to answer some of it. And just one last thing, Kubernetes is flexible. So if you are looking to run Kubernetes, you could go ahead and use services like Amazon EKS. That's not a problem. And like you asked in the earlier conversation that can I run Kubernetes on on-prem? Yes, you could. Kubernetes can run on local zone, can run on wavelength zone, can run on Outpost physical server, and we give you option for EKS anywhere, which means you may have your EKS cluster running in on-prem and you could connect it to AWS environment, and then management can happen from here and the actual work will happen on your cluster. So that can also happen.
So you mean
control plane in AWS, data plane in your on-prem environment, which you could manage. So you could do that. And if you say no, I don't want that, I just want the same Amazon Kubernetes version you are running on-prem, you are running on cloud on my own environment. So you could download a installable copy of Amazon's Kubernetes flavor and deploy it on your own cluster. That is what we call EKS distro. So it is an image, you download it, install it on your cluster, let it run independently. So that can another be reason that could be another option you could use if your environment is.
Okay.
Good. Makes sense. All right.
Yeah.
So I hope everyone has got some idea, and I to quickly summarize things. Thanks, Parna. Too many questions and interesting question, and hopefully everyone got some idea about how all these conversation work. So we have some giveaways that we have announced for our Cloud Career Journey book and from BizLab. So it's good that people are using these platform and getting the best out of it. So we would still have a giveaway which will be for selection based on the engagement. So please feel free to share information to your colleagues, to your network, and hopefully everyone will get benefit from this session. And we will be announcing giveaway winner. We announce it for week 09. So if you check if your name is in here, please reach out to us and we would be happy to help you out with your price. We may not have a process to just respond to every email, but we will try to respond to as much messages we can use. And Discord is a good method. Prasad is already on this console now, so Discord is where we would be happy to answer any questions you may have, so should not be a problem at all, right? Prasad, we did not have time for your session today. We were like overrun all the time.
But I loved it. The level of initially the overview, the history, and then the depth that we went into today. Amazing.
Good to hear that.
So is Discord buzzing with activity, Prasad?
I haven't checked Discord channel. Yeah.
No, the comment section was buzzing, but the Discord, hopefully it'll be, we'll all become active.
So Discord is a good way to engage us. So please go ahead and use that Discord channel to ask questions, share your knowledge, and don't be shy in sharing learnings you have. It may be a small step you have taken, but everything starts with a small step, right? You want to build a 10-story floor or building, you do not build 10-story directly, you start with first floor. So whatever you are doing, keep on sharing so that everyone will get inspired, and that will also help you eventually. That shouldn't be an issue. All right.
And how many have planned your exam? This is week 11. So
yeah,
anybody,
hopefully some
I
of
know,
the people are going for exams.
Yeah, I read that Sunil has booked his exam. What about the others? Anybody else? We would like to celebrate with you if you've gone ahead and booked your exams are already completed. Do share on LinkedIn as well about your accomplishments. We would really love to know.
Yeah.
What
So
about
yeah, if
cloud
you pass the
practitioner?
exam, or even if you do not pass, even if you book, put it
That's
onto
fine.
this, put it on LinkedIn, it would give you extra pressure that, hey, I put it on LinkedIn that I have booked the exam, now I have to pass it. So it is a indirect motivation you will get by sharing that you booked the exam. Digibodh has an exam on 30th June. Booked my exam. That's good, Mohammed. Thank you, Vijay. Thanks, Abhijit. July or August. Yeah, take your time. It is not a race. So take your time. If you feel you are not ready, watch videos again. Reach out to question on Discord. Any question which are bugging you, are not able to comprehend, put it there, and we'll try our best to respond to them. Shouldn't be an issue.
Yeah, like in the Discord channel, the technical questions channel, I see Anna asked a question, and then there was a discussion about it. So we can always have those certification questions, there, and people can kind of discuss there what the answer should be. I think, Ashish, what we can do is we can find a way that we can add so that people can poll on what answer is correct and stuff. We can find some plugin to do that.
Makes sense.
And I think everybody else also can answer. You don't have to wait for us to answer this question.
It's a community-driven program. So if we are busy and you don't have to wait for us to respond. If you know the answer, why not? Even if you do not know exact answer, you say that this is my guesses, and then we may think. And again,
reasoning behind it. Yeah, it's about open brainstorming, right? It's think out loud, brainstorm with each other that why a specific answer you think is right and why it is not right. Sorry.
True. So we just saw somebody has passed. Emmanuel has cleared the exam. So congratulations.
Really nice. Congrats, Emmanuel. Thank you for letting us know. So everyone, enjoy your rest of the day, and hopefully we'll be connecting again on Monday and share about your learning, whatever you liked. If any screenshot you want to put on LinkedIn, tag us so you know that you are helping others also be aware about the program. Thank you so much. We'll see you on to next week. Take care.
Take care. Bye.